Hey, this is part 2 of 14.2, proportions. How do I know if two ratios, fractions, form a proportion? Equal fractions, right? Okay, tell whether 6/4 and 8/12 form a proportion. Now, we can already tell that these are not equal, right? Because this one's greater than 1 and this one's less than 1, but here's the technique. First, we're going to try simplest form, 6/4. What is the greatest common factor of 6 and 4? 2. Factors are numbers that multiply into these products. And so when we divide both the numerator and the denominator by 2, we get 3 halves. Anytime you have 2 in the denominator, you can say it as halves. 8/12. What's the greatest common factor of 8 and 12? 4. You divide both 8 and 12 by 4, you get 2/3. Of course, 3 halves and 2/3 are not equal, and therefore these do not form a proportion. Not a proportion, not a, oh, look at this, I'm gonna have to write vertically pretty much. Oh, can he finish it? Can he do it? Oh, not really, but good enough. Okay, now the thing is with fractions is that they are unfinished division problems. So even though I know what 6 divided by 4 is, and I know what 8 divided by 12 is, if you take a calculator and you do 6 divided by 4, you get 1.5. So 6 over 4 is the same as 1.5, or 1 5/10. And if you take 8/12 and you divide it, right, you finish this division problem, you get, clear, 8 divided by 12, you get 0.666666666, 0.6 repeating. And clearly you can see that 1 5/10 and 6 repeating, 0.6 repeating are not equal, and therefore these are not going to be proportional. So it's kind of two different ways to do this, but typically we use simplest form. So to tell if two ratios form a proportion, write them in simplest form. I should have had you try that first. If the two ratios written in the simplest form are blank, then they form a blank. If they are equal, then they form a proportion. Wow, I gave myself a tiny line here. And he does it. Wait, no. Oh, and he does it. Not bad. Okay, now moving on to the next question. How do I know if the ratios in a table form a proportion? Okay, tell whether y and x are proportional. Compare each ratio y to x. So it's not in alphabetical order. It's backwards alphabetical order in simplest form. Okay, so here's what we got. We got x is 1/2, y is 3. So the first ratio is 3 over 1/2. And I know that looks weird. That's supposed to be a 1. This is called a complex fraction when you have like a frackwich. Okay, more than one fraction in a fraction. It's crazy. It does happen. Okay, the next ratio would be 6 over 1. Okay, I'm going to need myself some spice. I don't think that was grammatically right. The next one is y to x. Y to x, order matters. 9 over 3/2. And 12 over 2. Okay, what we're going to do is we want to write all of these with the same denominator. And typically what we do is we use what we call a unit rate or unit fraction. That means we want 1 in the denominator. So see 6 over 1, that one's finished. 12 over 2 is close. If I divide 2 by 2, I get 1. But then I have to divide 12 by 2, I get 6. So we know 6 over 1 and 12 over 2 are proportional. So I can say this row and this row are proportional. The other ones are a little harder. How can I write a 1 in the denominator? Well, if you remember with fractions, a fraction times its blank is equal to 1 times its reciprocal. So we're going to multiply both the numerator and the denominator by 2 over 1. I'm not writing it very well. But 3 times 2 is 6, right? The 1s don't matter because this is 3 over 1. So this becomes 6 over 1. Hey, now it turns out that this row is also proportional to the others. And finally, the last one, how do we get a 1 in the denominator? You multiply by the reciprocal. Any fraction times its reciprocal is equal to 1. So I have to multiply 9 times 2/3. Technically, that's 9 over 1. So that'd be 9 times 2 is 18 over 3. That's 6 over 1. Hey, they're all proportional. Woo! Okay. So tell whether y and x are proportional. The ratios y to x, that should have been a y. Look at that. You just make that thick enough and it becomes a y. Y to x are proportional. Well, I'm going to have to go down below. Give me my scuba gear. All right, here we go. Write each ratio y to x as a unit ratio or unit rate, right? It's like a unit rate. It's having one denominator. When dealing with a fraction in the denominator, multiply the numerator and the denominator by the blank of the denominator, the reciprocal. Cool. Awesome. So let's compare the first way and the second way. This one we were writing in simplest form. In this one, we were writing a unit ratio, 1 in the denominator. What do they both have in common? Well, the idea is that you're trying to get the same number in the denominator to check if the fractions are equal. And if they're equal, then they form a proportion. Awesome. We are on to the last question. El fin. Are you ready? I'm ready. Okay. How do you know if let me get there we go. How do we know if two quantities are proportional to each other? Okay. A new frozen yogurt store opened this summer. Oh, summer, you seem so far away. That sells its yogurt at a price based on the total weight. That makes sense. The more that you get, the more you pay. Each member of Isabel's family weighed their dish, and this is what they found. Determine if the cost is proportional to the weight. Now, I don't know if you all see that. Cost proportional to the weight. That means we want money over weight. Money over ounces in each one of these. So we're going to have to compare all of them. So $5 for 12.5 ounces. I didn't leave myself enough room. Okay, and we need to compare that to $4 over 10 ounces. Okay, and then I'll make a line. And then we have $2 for 5 ounces. And $3.20 for 8 ounces. Okay, well, what do you think is the best thing to do here? Should we write these all in simplest form, or should we use unit ratios? I hope I hear you out there saying, unit ratios, Mr. Plunkett. Right, we want ones in the denominators. We want 1 ounce, it's like a unit rate, isn't it? Those unit rates are coming back to haunt you. I know you're scared. Don't be scared. They're not hard to find. I'll show you how. 1 ounce. I don't know why I keep doing the 1 last. This time I'm going to do the 1 first. 1 ounce. There we go. Okay. How do I get from 12.5 to 1? I divide by 12.5. Now what do I have to do with 5? Divide by 12.5. 5 divided by 12 and 5/10 is equal to 0.4. What does that mean? 40 cents an ounce. Nice. It's kind of the cost of gas right now. Okay, from 10 to 1, how do I do that? I divide by 10. Now I have to divide 4 by 10. If I divide by 10, the decimal just moves over. That's 40 cents per ounce as well. That's beautiful. Now I divide by 5 to get to 1. 2 divided by 5. That's like 2.0 divided by 5. That's equal to 0.4. So far, so good. These are all proportional so far. How do I get from 8 to 1? I divide by 8. What do I have to divide $3.20 by? 8. 8 goes into 3.2, 0.4 times with a 0 on it. These are all proportional. I'm sure you don't actually really care. I care though. I care. So everything's 40 cents per ounce. To determine if the cost is proportional to the weight, write each rate with the blank in the numerator. With the blank in the numerator and the blank in the denominator. The cost in the numerator and the weight in the denominator. Okay, good. Whoa. Write each rate as a unit rate. If all the unit rates are equal, the relationship is proportional, and they are. You are all amazing. You just got through 14-2. What are proportions? Fractions that are written in an equation, fractions that are equal. And so all these fractions are equal, and therefore they are proportional. I'll see you the next time.